Welcome back to my YouTube channel. So in today's assignment, we are going to complete the Kaggle 3, day 3 by Kaggle. So first of all, we will listen to this summary podcast. So you can watch it. That is context engineering session memory. So you can listen this. So after that, you have to complete the podcast and you can read this. So you can download it also. Context engineering session. So we will click on download here. So in this, their introduction to context engineering and sessions in memory and context engineering. So you can read it. And there is a flow chart also that is for flow of context management of four agents. And ahead there is detail about sessions. Alright, so you can read it. This is of 72 pages. You can read it. So after that, you have to create and build stateful agents and perform context engineering. So this is the agent session you have to complete. So you have to click on copy and edit. So this is the first part, that is memory management part one session. So in this tool, you will learn what session are and how to use them in agent. So how to build stateful agent with session and events and how to persist session and database. Alright, so you can start it. First of all, you have to do the same thing. You have to add the key. So I will add my key. So I will copy my key. And then you have to select no secret. That is. So now save. Then check mark this button. Now you can run this session starting now. So Gemini API key is at complete. So now we have to import ADK components. So now we will import the specific component that you will need the from the agent development kit and the generative AI library. Just keep your mind organized and have it is like previous step we did. So ADK components import successfully. So now we will learn helper function and helper function that manage the complete conversation session that handling session creation retrieval and query processing and response streaming. So let's support both single queries and multiple queries in these sequences. Alright, so return helper function defined. Now we will configure retry option also. So now section 2, this will be session management. So it is the problem given the code large language models are inherently stateless and their awareness is confined to information you provide in a single API call. This means an agent without proper context management will react to the current prompt without considering any previous history. Alright, so why this matter? So imagine you are trying to having a meaningful conversation with someone who forgot everything you have said each after sentences. This will challenge that's the challenge we face with query LLM. So what is session? Session is a container of conversation. It encapsulates the conversation history in a chronological manner and also record all tools, interaction and responses in a single continuous conversation. Oh, so a session is tied to a user and agent. It don't share with other users. Alright. So this is the diagram for that is session, agentic application with the user with session. There are session events and session states. So how to manage sessions? So agentic application can have multiple users and each have multiple sessions with applications. To manage the session events, ADQ for session manager and runner. So session service will be the storage layer. Also the it manages the flow of information between user and agent. So session equal to a notebook and events equal to individual and tie in a single page and session service equals to the filling cabinet, so in notebooks and radar equals to the assisting managing the conversation. So first of all, we will implement our first stateful agent. So let's run this. Cross stateful agent initialized. So application default and user default using in memory. So far, now we will test our stateful agent. So it is running now. Session stateful agentic session. So user I am Sam. What is the capital of United States? So Germany will run it. Hi Sam. The capital of States is Washington. So user hello. What is my name? Your name is Sam. All right. So this is the example of stateful agent. All right. So this is the optional. You can run it. So you ask on the capital of United States. So what's my name? What's your name? So this is now we have created the example also. So now what is the problem here? The session information not persistent. That is meaningful conversation are lost. While the advantages in test environments in real world, a user should be able to refer from past and resume conversation. To achieve this, we must persist informations. So persistent sessions with database session services. While in-memory session services are great for prototyping and real-world applications, need conversation is to survive, restart, caching deployments, let's develop persistent storage. So we will choose the right session service. So let's implement the persistent session. So let's start it. This is upgraded to persistent sessions. Database my agent.db session will service stats. So first of test will be we will verify persistent. Hi, I'm Sam. What is the capital of United States? So hi Sam. The capital of United States is Washington. All right. So now this option you can run it also. Let's run it. All right. So we run this also. Let's verify that session that is isolated. Alright, so how the events on database. So since we are using SQLite DB to store information, let's have a quick peek to see how information is stored. You can see that we have to import SQLite, so that is SQL. So we will check it. In this way you can check. Alright, so now we will see context compaction. Alright, so as you can see, all the events are stored in a full in a session database, and this quickly add up for a long or complex task. This list of events we can become very large. So it's reduced the performance and higher cost. But what if we could automatically summarize the past? Let's use ADK context compression feature to see how to automatically reduce the context that is stored in the session. So you can see that. I will zoom it. The session ID and this is the code. So first we will complete text into parts. We will use NLP here, and what is the role that is user. So grounding metadata which is known. Then after that we will add parts like for example text. Okay, I understand your favorite project is project alpha. Right, so then role equals to model. So this is the sample session data, and it send to context sent before completion, then it sends to agent. So after context convection it will be sample system data. Alright, so we will create an app for the agent. So let's run it. So it research app okay with event but you can ignore it. And now we will running the game. Let's run it. So let's get started now. And it's answering also in diagnostic and imaging also, and generative AI for the discovering development also is running. So now we will verifying compaction in the session history. Let's run this also. So it is searching for the compaction summary event. So it is a you can see that it found the compaction event. Growth will be user that I explained the diagram previously. So what you are accomplished, but that is we will learn here today. That is automatic contact management. So you just found the proof. In the present of that event is the session is tangible in result of the compaction process. So what you did today is that is you use silent operations background and verify result. So there is a most construction option indicated that is custom compaction context caching. So now the problem is while we can do context compaction, use the database to resume a session, we face a challenges now. In some cases, we have some key information friends that we want to share across other session. In this scenario, instead of sharing this entire session history, transferring information from a few key variable can improve the session experience. Let's see how to. So let's working with session state. So first we will create custom tool for session management. Let's run it. So it's tool created now. Now we will creating an agent with session tool state tools. So it's also initialized. So now we're testing session state in action. So it's done also. You can see. So now we'll get it on. Let's run again. Now it's fine. So session state contains that the username will be same and user content Poland. Alright, so now we will create session state isolation. So it's run also. So now we'll start in cross session state sharing. So now we will do cleanup. So that is we did clean up all database files. So this is a congratulations, you did it. And there is no solution required. It's not your practice and learning only. So alright, so next we will do system long-term memory parts too. So why do we need memory? So we use these are reference and habits and past interaction their outcomes, domain knowledge and expertise levels and communication style and patterns. So let's run part two. We will see in detailed explanation. We can save it. Alright, so now that we did, now I'll do part 3B. So you will click on copy and edit. So this is the memory management part 2 memory. So what is memory? Memory is a service that provides long-term knowledge storage for agents. So key distinction will be session equal to what is session, that is short-term memory, that is single conversion, and memory equals to long-term knowledge across multiple conversations. So why memory? Memory provide capabilities that session alone cannot. So capability will be cross conversation recall, let access information from any past conversation, and the intelligent extraction and semantic research and persistent storage. Alright, so what we will learn here, we will initialize memory service, integrate with the agent, and we will transfer session data to memory storage. And we search and retrieve memories, and we automate memory storage and retrievers. We will understand memory consolidation also. Alright, so we will start with Google Tattoo, that is usually process we did, and now we will click on add-ons, click on secrets, then we have to add secret key, that is Google, and let's save it. So now we try to run it. Session is starting. So Gemini API key setup complete. So now we will import ATK components. So now we will import the specific component we will need from the agent development kit and the generative AI library. So it's running. So ATK component also imported successfully. Now we will have to help function. So now we will configure AI options. So now we will in section 2 we will see memory flow, workflow. So there are three steps in the integration process. First one is initialize, and second one is ingest, and third one is retrieve. So we will in initialize we will create a memory service and provide it to agent to via the runner. And in ingest also we will transfer session data to memory using add session to memory. And in retrieve also we will search stored memories using search memory. So let's explore each step in the following session. So first of all we will see memory initial service added through agent. So memory service is provided to agent and then transfer session data to memory and memory service transfer to agents. Then memories agent provides service to memory service. All right. So section three also we will learn. That is, we will initialize memory service. So now after that we will add memory to agent. So we will successfully agent created. Now we will create runner. So this is an important configuration was uses this adding memory service to the runner makes memory available to agent, but it doesn't automatically use. You should use explicitly like that. So it's created now. My favorite color is blue green. Can you write a haiku about it? So it's written that they use NLP here. That is natural language processing, occur as also branch. And blue green are beautiful blue, and that is nature's calm MS. Alright, so now we will verify the combination was captured in session. So this is the output here. Now we will session to memory. So now in section 5 we will enable memory retrieval in your agent. So you have successfully transferred data to memory, but there is one crucial step remaining. Agents cannot access to memory service, but they do need tools to research it. So let's do it. We will add load memory to agent. Alright, so agent will load memory to get it. So now you can ignore the line. So that is what is numerical? My favorite color is blue green. That is previously stored. Now we will complete manual workflow test. Let's run it. So my birthday, so you user enters my birthday is March 15th. Okay, I will remember it. Your birthday is on March 15th. Alright, so now I have to say what is search near to memory. So now let's check it. When is my birthday? So my birthday is on 15 March. Alright. So now we will use manual memory search. Let's see, you will found for readable memories. That is your favorite color is blue green and my birthday is 15 March. Alright, so now we will return that. We will just different queries. Let's see. These are the automatic memory storage that is callbacks, common cases. This like before the callback agent is transfer model tools. Alright. So now this is the automatic memory storage with callbacks created. So now we'll create an agent with load and upload memory. So it is created with automatic sequencing. Now we'll create a runner and test the agent. Now runner is created now. So we'll test it. That is auto memory. Now we will in section 7 we will memory consolidation. So that is the limitation of the raw storage. What we need so far. You can see that that is the sample session data, that is sample memory. Now we will how consolidation works. So first you will do raw session events, then LLM analyze conversation, then extract key effects, then stores concise memory and one with existing memories. All right. So you did it. So congratulations, you learn memory management and you learn adding memory, storing information, searching memory, retrieving in agents, memory consolidation. We will extract key information from session data. Alright, so thank you so much for watching this video. Hit the subscribe button and don't forget to subscribe my YouTube channel. So in next day 4 we will learn how to implement observability and evaluate your agents to ensure they are working in entire production. Alright, so thank you so much for watching.